Good morning class. So today we shall see the tropane alkaloids. So one of the very important drug of tropane alkaloids is datura. We can see the fruit of datura and the flowers of datura over here. So let's go ahead and check the next features of tropane alkaloids. These are the ester alkaloids. Ester alkaloids. So you should remember that it should have an alcohol and an acid. The parent base is called as the tropane base. See here we have the tropane base. It is an 8-methyl 8-aza bicyclooctane. The tropane alkaloids are classified into two types. One is the solanaceous and the other the erythroxylon. The solanaceous tropane alkaloids belong to the Solanaceae family. The erythroxylon belongs to the Erythroxylaceae family. So let's see the solanaceous drugs. We have datura stramonium, Atropa belladonna and Hyoscyamus niger. Check the flowers of these drugs. This is a funnel shape or a tubular flower. This is a campanulate or a bell-shaped flower, and these flowers have a yellow corolla with purple veins. Further, let's see the synonyms. We have thorn apple leaves for datura stramonium, deadly nightshade for Atropa belladonna, and stinking nightshade for Hyoscyamus niger. They all come from European countries. The Indian variety of datura stramonium is datura metal, of Atropa belladonna is Atropa acuminata, and of Hyoscyamus niger is Hyoscyamus albus. The amount of alkaloids present in all these three species differ. We have 0.25% in datura, 0.35 in Atropa, and very less concentration, that is 0.05 in case of Hyoscyamus. Now there are some interesting stories about Atropa belladonna and datura stramonium which is given in these slides. Very important one is the word belladonna means beautiful lady, because Atropa has a mydriatic effect, and because of which it was used in previous years for cosmetic property, wherein it could increase the pupil size in women. Let's see the leaves of these drugs. We have the datura, this is Atropa, and the Hyoscyamus. You can see all of them have an acuminate apex. The shapes of the three are different. You have triangular, ovate and rhomboidal ovate. Check this. These are having a dented margin, and even Hyoscyamus has a dented margin. The base, this is asymmetric, symmetric and asymmetric base. Check the venation. Venation, all of them have reticulate venation, but this angle from midrib to the veins is 45 degrees in case of datura, and in case of Hyoscyamus this angle is 45 degrees, whereas in case of belladonna is 60 degrees. The surface of these leaves have calcium oxalate crystals, and because of which it could be rough or it could be sticky because of the trichomes present. The stomata, all of them have the anisocytic stomata. You can see them, anisocytic stomata. This is the datura fruit, that is the thorn apple. See, here are the trichomes. In case of datura, we have the non-glandular, that is the covering trichomes, uniciliate covering trichomes. In case of belladonna and Hyoscyamus, the covering trichomes have a glandular head. You can see over here, they have a glandular head. Apart from this, the Hyoscyamus also has a branched trichome. So all these are examples of the covering trichomes. They also have a glandular trichome with a stalk. They have the glandular trichomes with a stalk. Now, this is a very important character of all the three species, calcium oxalate, because we can differentiate them by this calcium oxalate crystal shape. In fact, the adulteration of each of the constituents can be differentiated. The adulteration of each of these leaves with each other can be distinguished by this calcium oxalate crystals. Belladonna. Belladonna has microspheroidal or sandy crystals. You see here, they are in the form of dot, 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 a number of them. Whereas Datura stramonium, it has cluster crystals of calcium oxalate. And Hyoscyamus has twin prisms of calcium oxalate. So this way we can differentiate between all the three species of tropane alkaloids: Atropa belladonna, Datura stramonium and Hyoscyamus niger. Now let's see the microscopy. Microscopy, this is of Datura stramonium. Datura stramonium, you have a U-shaped vascular bundle. Vascular bundles are U-shaped. Here it is crescent shaped. This is belladonna, crescent shaped. And Hyoscyamus, the midrib is equipotent. It is an isobilateral leaf, and you can see that the midrib is present in the same amount on both the sides of the vascular bundles. The main constituent of tropane alkaloids is atropine, hyoscyamine and hyoscine. The most important one is the levoisomer hyoscyamine. Its stable racemate, which is atropine, that is plus minus, and hyoscine, which is also a levoisomer and called by the name scopolamine. These all are ester alkaloids. And therefore they can be hydrolyzed by heating at 60 degrees Celsius. Atropine yields tropic acid and tropine, whereas hyoscine yields tropic acid and ocene. Actually, it should have been scopine, but scopine is unstable and it gets converted into its geometric isomer, which is ocene. Here is the structure of atropine. You can see it's a racemate mixture, whereas hyoscyamine has the similar structure, but it is a levoisomer. So it has a ester. So ester means an alcohol and a acid. So here is the alcohol base. OH would have been over here. The tropine alcohol, tropanol, and the tropic acid. So this is your tropic acid. So alcohol plus acid gives us the ester alkaloids. This is scopolamine. The major difference is this ether linkage in the 6th and the 7th carbon. The ether linkage over here. Otherwise, you can see the structure remains the same. Comparing the constituents of Datura, Atropa and Hyoscyamus, principally the amount of hyoscyamine is more in case of Datura and Atropa, whereas hyoscine is nothing but scopolamine. That is the principal alkaloid of Hyoscyamus niger. Now we also said that Hyoscyamus is called as stinking nightshade. So that stinking is because of tetramethylputrescine. Apart from hyoscine and hyoscyamine, the belladonna contains some volatile bases, which is pyridine and N-methylpyrrolane, a fluorescent compound called as methylasculatine or scopolatine, and Datura stramonium contains fixed oils and minerals. The most important chemical test of Datura alkaloids are Vitali-Morin's test. What is the activity of this drug? It decreases saliva and GIT secretions, hence it is used in pre-operative conditions. An antispasmodic agent, and I already told you it's a mydriatic, belladonna. Hyoscine has a central effect, producing a sedative and hypnotic activity, and it is also used as an antiemetic agent. So these were the alkaloids which belong to the Solanaceae family. Let's see the alkaloid which belongs to the Erythroxylacea family. These are the leaves of Erythroxylum coca. Now coca, this is the plant which gives you cocaine, which is your narcotic drug. Coca, it is present in the leaves, the cocaine, the main constituent present in the leaves. Apart from cocaine, it also has cinnamoyl cocaine and alpha-truxylane. The base, there we had a tropane base. Here what we have is an echogonine base. Echogonine base. The difference is apart here. Here is the difference where you can see there is an additional COOH group. An additional COOH group. So this is the echogonine base, and cocaine we know is used as a local anesthetic, but however it's a narcotic drug, a seducing drug, so we do not use this. Major alkaloid, cocaine is a diester alkaloid. We have one ester over here and here. So what's the difference? The echogonine base and the constituent, the acid, is benzoic acid. In case of tropane alkaloids, we had tropic acid. Here we have benzoic acid. Heated at 160 degrees Celsius in presence of conc HCl hydrolyzes the cocaine to give methanol. Methanol will come from here. The echogonine base, and benzoic acid. So that's the tropane alkaloids. Next class we have is the Vasaka or the quinazoline alkaloids. Quinazoline alkaloids, we have one important drug which is Adathoda vasica. Leaves of Adathoda vasica, family Acanthaceae. It's an Indian drug. We do have it in our medicinal garden. If you see the morphology of this leaf, it's got an entire margin, an acuminate apex, the base is tapering and it is symmetric. The venation is pinnate and reticulate. And the shape of the leaf is lanceolate. Lanceolate, like a scale, lanceolate shape. See the microscopy of Vasaka. There are three important characteristics of the microscopy of Vasaka when compared to any other leaf. One, it has a diacytic stomata. Second, it has uniseriate covering trichomes, but important is the four-celled head glandular trichome. It also has cystoliths, which are calcium carbonate crystals. Calcium carbonate crystals. A dorsiventral leaf, you can see the photographs of diacytic stomata here. Diacytic stomata, this is the glandular trichome, caudery head glandular trichome. The diacytic stomata, the xylem vessels, which are spiral in nature. The major chemical constituent is the quinazoline. When I said quinazoline, aza group, you can see two nitrogens. So this is the difference between quinoline and quinazoline. Quinoline, we have only one nitrogen. Quinazoline, we have two nitrogen. So the two important constituents is vasicine and vasicinone. The difference is this ketone group which is present because ONE, vasicinone. The use of the drug, it's for bronchitis and asthma. We all know this. Adulsa, very important drug in Ayurveda, used for bronchitis, asthma, relieves cough. It's also used in some bleeding conditions to stop the bleeding in idiopathic conditions. Such unknown conditions if bleeding occurs, can try and give Adulsa. Also gives a relief for pyorrhea and bleeding gums. That is the same thing. Adulsa can be given. So this were the class of tropane and quinazoline alkaloids. Thank you.